Hello everyone, myself Dr. Jyoti Mandala. Welcome you all to the video lecture series of C programming language. We are in our lecture number 44. In this lecture, let us learn about what actually storage classes are nothing but. So we are in the concept of functions where we learned about what actually function is, how a function can be declared and what are all the different types of functions we have and how arrays and functions can be combined. So if you have not learned this concept, I request you all to go through the earlier videos. Right, so in today's class we'll see about storage classes. Now what is actually a storage class is the use of this storage class is it defines about the scope and the lifetime of a variable. Like whenever you're declaring any variable, it can be a variable declared within the function. You all know what actually a function is, or it can be declared outside of the function also, because we learned a variable can be a local variable or a global variable. Now what do you mean by the scope is nothing but within which part, like within which line of code the variable is visible, and lifetime is nothing but the number of lines of code through which from the starting to the ending, like within the function or throughout the program, that is nothing but lifetime. Got it, all of you? So storage classes talks about the scope. Scope is nothing but visibility where the variable can be accessed, and lifetime, that means whether the variable is can be within the function, or its lifetime is within the function or throughout the program, like means throughout all the functions, like that it will be defined. So that can be taught by using our storage classes. We all know in a program we can have multiple functions. So if you have multiple functions, we'll be working with number of variables. So for all those variables, so what type of variable will be having what type of scope and what type of visibility, that will be learning by using these storage classes, right? So normally we have 4 types of storage classes which can be applied on variables, where those 4 types of are auto, register, static and extern. So we will be learning all these 4 types in detail, but observe here all these 4 names, whatever I have written here, auto, register, static and extern, are all are keywords. So you need to use with in the small letters only, the way they have been defined. Okay, so to understand this concept, for each storage class we will be learning what is the storage place. That means whether it will be stored in RAM or it will be stored in memory. Not memory, it will be stored in registers or a RAM, or what is the default value. That means if no value is assigned, what will be the default value, and what is the scope. That means is it a local variable or a global variable, and lifetime, that means can it be used throughout the program or it can be used in a specific function. So we will be learning of all these 4 points in our future slides, and we will be filling all these values in our future slides. Okay, so let us learn with first type, that is auto. Now auto storage class is nothing but whenever a variable is declared inside a block, then it can be considered as a auto, or it can be also called as a local variable also. So as of now, whatever local variables you have used, all are called as automatic. Auto stands for automatic variables or local variables. So by default, if you don't write any storage class within the declaration of a variable, then it will be considered as an auto only. Okay, so the local variables should be existing within only inside a block, and in which it has to be declared. Okay, so the keyword that we need to use to make any variable as an automatic variable is AUTO, but if you are not mentioning, by default it will be considered. Okay, and the memory for this automatic variables will be allocated at runtime only. It will not be allocated at compile time, it will be allocated at runtime only. So whenever you are saying local variables, we can say the visibility will be within that block only, where it has been defined, right? And the scope of the automatic variable is limited to that block only. That means that is visible, that means that can be used. So as the visibility is like that, so we can say the scope is limited to that block only. Okay, so if you know value is assigned to automatic variables, then the initial value will be the garbage value. For understanding this one, we'll see an example. Okay, so let us see the example. If you see this one, Let me increase this one. If you see here, I have declared two variables A and B, and A and B values I have not initialized, and by default if you have not initialized anything, it will be by default auto, or else you can simply put AUTO like that also, that is also okay. Int A and auto int A within the function both are same. By default the storage class is auto only. So if you are not mentioning any data type, and if you are trying to compile, and if you are trying to display the values, then you can check here, you will be getting a garbage value. One is an integer value, the other one is a float value. So you will be getting a garbage value. Got it, all of you? So that is what it was told, like whenever you are trying to display any value without initializing any value for an automatic value, a garbage value will be assigned by default. Garbage value is nothing but a random value will be assigned, and the memory assigned to automatic variables will be removed upon exit from that block. So once it will be coming out of that block, that memory will be freed. That means that memory will be empty. Got it, all of you? So with this information, let me show you one more example for automatic variables, where you can see this example where I have taken one variable called A equal to 10, and I have printed that variable A. Now if you see, I have created one more block, and within that block I have declared and initialized A value with 20 again, and I am trying to print A value. Observe here, A has been initialized once again, and then after closing this block I am trying to print this A value once again. And what happens here? If you check the output of this program, observe here, the value of A, this 10, will be from here to here, and this value of A is 20, which is declared within this block, so its scope will be from within this block. Outside of this block, the value of A will be again 10 only. Got it? Let me show you the output. It will be more clear to you. What is our expected output? The first one will be, first statement will be 10, and the second output will be 20, and the third one will be 10 again. So let us check that one. So you will be getting 10, 20 and 10. Got it? So, but if you see, if you remove this declaration, if you write A equal to 20 again, then what happens? To this A value, this will be considered, for this memory will be allocated, and that in that memory location it will be like, what do you mean by that one? It will be overridden. I will be removing this one. I will remove this CLR so that you can check with the earlier output. So if you check, if you see what happens, earlier output is 10, 20, 10, and now we are getting 10, 20, 20. That means whatever value you got here, that will be taken here. But if you are declaring once again, then the declaration will be considered within that block only. That means 20 will be within this block only, and here it will be taking this value. Got it, all of you? This is how, what do you mean by that one? Auto storage class will be working. Okay, so you can come, like you can say like the auto variables, whatever you are saying, that will be stored in RAM, and the default value will be the garbage value, and the scope will be local, and it will be within that function only. That means if you have two functions, the variables in one function cannot be used in the other function. That's why we can say this is within the function only. Right, all of you? So let us see the other one, that is static storage class. What do you mean by static storage class? Is nothing but whenever you want to use this one, we need to use a keyword called static, and these variables are defined as static. What do you mean by that one? We will be assigning the value. That value, whatever you are assigning to that variable, static variable, will be assigned only once, and the number of times you will be calling that one, that will be whole. The value will be whole. To understand this one, I will show you one example. Okay, so static local variables are visible only within that function. Okay, so the same static variable can be declared many number of times, but it can be assigned only once. So to understand this one, let me take one example. So let me show you that code. So if you see here, I have taken a main function. This is the main function, and within the main function I want to call this show method, and this show function will be called 3 times. Now coming to the show function, within this show I have taken a variable called int A, and this is of static. I told you static variables will be declared only once. So let us call for I equal to 0 for the first time, I value is 0, it will call the show function, it will come here and it will initialize the value a equal to 10 and we will be getting an output of a equal to 10 and then a value internally will be incremented to 11. It will this is the end, it will go back and I value will be incremented, which is again a condition true, so it will call the show method once again. Now what happens, it will come here, as this is a static variable, it will not initialize this value of a equal to 10 once again. Whatever the incremented value we have, that will be retained. That is what I am trying to tell. The value, the static variable value will be retained among the function calls. So the value of a will be now 11. Now that will be printed and then the value of a will be 12 internally. Again it will go back here and I value will be incremented, show will be called again. Now a value will be 12 internally, that will be printed. Let me show you the output. You can check here, a value equal to 10, 11 and 12 it is printed. That means we can understand from this concept what we can understand, whatever we have, whatever variable value we have, that value will be retained. That means the value will be held within the multiple function calls. That is what we can understand. And the default value of a static variable will be a 0 value. If you are not assigning any value, the value will be 0 by default. Okay, so it is a global variable. Why? Because it is retaining its value, so it is a global variable. So by this we can fill this table, which is RAM, storage is RAM, default value is 0, scope is local and lifetime is throughout our program. Let us see the next one, that is extern. Extern is nothing but your global variables. So if you are declaring any variable outside of the function, then it is called as a global variable. And the external storage class is used to tell to the compiler like the variable that has been defined as extern is declared somewhere in our program, and it can do the linking automatically. How that can be linking, I'll show you with an example. So I'll show you the compiler. Let us take this example. In this example, you can see I have taken main function, and in this function I have taken a variable called a and it has been declared as an extern. So whenever you are saying extern, then what the compiler will do is it will understand like somewhere else in the program, throughout the program, the variable a has been initialized with some value. So here if you see, the main function has been closed here, but after this we have initialized the value of a as 20. So this is okay. So whenever you are using extern, extern stands for the compiler can understand the variable has been declared somewhere else. So if you compile this one, and I am trying to print this value of a, and if you compile and run, you can see the output a value will be displayed as 20. But observe here, you cannot initialize the value of a directly here, because initialization and the external keyword cannot be combined at once. So if you do like this, it will be throwing an error. So you can't do that one. External variable cannot be initialized. That is what it is showing here. You can't do that one. And also one more thing, if you don't initialize any value for an external variable a, then the default value, what it will be, let me check that one. So the default value will be 0. Right? So these are the things you need to understand whenever you are talking about the extern. So the variable can be allocated memory at the time of initializing, like the variables declared as extern are not allocated any memory, only it will be declared by using the extern. Okay, and the initial value will be the 0 value. And it will be used throughout the we can only initialize the external variable which is global, like means throughout the program the value can be used. No, it is not specific to a particular block. Okay, so and the external variable can be declared many times, but it can be initialized only once. Got it, all of you? So we'll see this one. The storage space will be in the RAM only. The default value will be 0 and it is global, and through the end of the program, so throughout the program it can be used. The next one is register. Register is nothing but very simple. Here what happens is whatever value you assign to any variable, that if you want to store instead of memory, if you want to store in the register, then it can be done by using a keyword called register, and it depends upon the compiler whether it want to store that one in the register or not, because if registers are not free, then it has to store in the memory only. And we can use and we cannot use with the static keywords, and we cannot use pointer to the registers also, because the registers don't have any address. Got it all of you? And the initial value for the register will be a local variable which is a 0. Always register variables should be a local variables only. And whenever you use registers, it will be accessed. That means we can get the variables value with less amount of time. So with this, we can see the storage place is register, garbage value will be the initial value, and information will be local and within the function. With this, we'll come to